Hello guys, hope you are doing well. Today we are going to discuss the LeetCode problem Sudoku solver. So as you already know that in the Sudoku we have to place number 1 to 9 exactly once in each column and each row and each subgrid. So we have to place the numbers 1 to 9 in each of the column and in each of the row, but we have to check that if there should not be duplicates in row and there should not be any duplicates in the column and there should not be any duplicate in the subgrid as well. So how we can solve this problem actually? So we can solve this problem like by placing integers to the empty cells and then checking if that is valid configuration or not. So how we will check that this configuration is valid or not? For checking validity, we have to check three things like if there is any duplicate entry for that element that we are putting is already present in corresponding row, corresponding column and corresponding subgrid. So that means that is wrong configuration, as it is already said that Sudoku should have 1 to 9 integers uniquely in each row, uniquely in each column and uniquely in each grid. So if that these conditions violates, then we cannot place that integer or like you can say character in the corresponding grid. So we have to try all the possibilities, like we can put here 4 5 6 7 and then check if it is valid or not. So in this way we can proceed. So in the similar manner we can like we have to explore all the possibilities and check whether it is valid configuration or not. And here one more thing is given, like empty cell is denoted by a dot, single dot, and otherwise the characters are being filled, already filled actually. So let's see another constraint if any is given. So it is guaranteed that input board has only one solution. Okay, so it is given that we have only one solution. With that we have to come up. So how we are going to solve this problem actually? So as you know that we can all easily check if the element is duplicate in a row, if the element is duplicate in a column. So how we are going to check if the element is duplicate in the grid? So how will we will try to find the number of grid actually, which number this element belongs to. So if somehow we are able to find which grid this number belongs to, then we can easily check actually. So how we are going to find the like grid? So grid we can find like, let's say let's say I and j are given, or row number and column number, and we know that each row and each column of means like there are 9 rows and 9 column in the this Sudoku matrix. So how we are going to like our grid index would be would be I divided by 3 star 3 plus j divided by 3. So this will give us the grid number actually, grid index, which is grid this particular ij belongs. So using this grid index formula, we will check if there is an if the current integer is already present in the grid or not. So for checking this thing quickly without traversing the this matrix, we can keep like hash set, array of hash set, one hash set for each grid, one hash set for each row, one hash set for each column. So quickly we can check order in order of one time, we can check if there exists a duplicate or not. So let's jump into the problem directly. So as we said, we will need to keep one 9 hash sets for the column, 9 hash set for the rows, and 9 hash set for grids. So let's make hash set. So set integer row, set integer column, set integer box, you can say. So let's make a function to initialize them. Let's name it init. So we can initialize them like row equal to new hash set 9, column equal to new hash set 9, box equal to new hash set 9, and let's initialize all of the column, all of the row, and all of the box hash set. Row equal to let's copy paste it. And box I. So these are our boxes, columns, and row. And let's take another variable board. Let's start board equal to board. So let's insert already present element into corresponding row, corresponding column, and corresponding boxes. So here we'll try to insert it. So for int I equal to 0, I plus plus I equal to j equal to 0, j equal to less than 9, j plus plus. So if board I comma j is not empty, then there is an element. So let's take that element I comma j minus 0 will give integer representation of that corresponding char. So let's say there is another function place that can insert this value into corresponding row, corresponding column, and corresponding box. So I, j, and k. Okay, so let's implement here place to val. This is val. So let's first calculate grid index. So as it is already given, it is this one. So what we will do, like we will row I dot add value, column j dot add value, and grid I dot add grid. No, it is box actually. Box idx dot add value. So we have placed this, we have populated this, our corresponding row, column, and box with the value that is present. And let's make it so that this function can be used when we are going to place an arbitrary integer into the cell. So we have to place that here. So we can make that like board I comma j char value plus 0. Okay, so I have placed that, and let's call this function init from here. Okay, it will initialize the board. Now we'll try to place from 0 comma 0 from the starting of the board. So we'll check for the base actually we what we are going to do, like we will first try to place all 1 to 9 digit in first row, and then we will going to place in 1 to 9 digit in second row, and so on actually. So we'll check if our j is greater than 8, then we know that we should move to the next row actually. So in that case I plus plus, and we'll check like if I is also greater than 8, that means we have completely filled our grid. So we need to take an indicator so that we would know that grid is already filled. So let's take a boolean variable filled, that is false initially. So filled equal to true, and we will simply return that in the base condition. And if that is not the case, then what we will going to do, like we are going to check if there is any integer is already present or not. If it is present, if board I comma j equal to dot, if it is not present, then we are supposed to place here. So what we will do, like we will try to place integers from 1 to 9. Placed here 1 to 9, and we'll check if it is. Let's create one more function that will check if we can place it here or not. That takes I j k. Okay, let's create a function valid boolean valid j and where. So we'll have to calculate grid index here, box index as well. So we'll check if box index dot contains val is false, and row I dot contains val is false as well, and column j dot contains where is false as well. This is also false. If the value is not present in corresponding row, corresponding column, and corresponding box, then we will return true. Else will return false. So if it is valid, then we try to place it valid. Then we try to place I, j, and k, and we'll recursively call for next cell in our board. So we'll call solve, and we are processing it column by column across a row. So we'll go to we'll check if our entry is solved or not. If filled, if it is completely filled by making this move, then we should simply return because we know that we got the solution. Otherwise, we have to revert the change. So how we revert the change? We have to create an method unplace that take I, j, and k. Let's create that. Where is our place? This is our place here. Let's make it unplace one more method. Unplace I int j and well. That means let's copy it. RDX is going to, what we are going to do? We are going to remove the entries. Row dot remove where column j dot remove where and box rdx dot remove well, and we have to change the board as well because we have added it to the board as well. So board ij equal to dot. So this is the place method. Okay, so and if it contains some digit, then we simply move to the next column in same row. Else we go for solving in correspond next column. Actually we are moving across row. So in the first row, first we will go for first column, and after that we will move to the second column in the first row and the third column in the first row, and so on. So if there is a blank entry, then we will put some integer and then try, and if it is already present there, then we simply skip it and go to solve like next column in the same row. And if the column end is reached, so here you can say that if column end is reached means like j is greater than 8, then we know that we have to switch the row. So I have made it here. So let's see if it runs or not. So it is giving error and place. We have to make it void or something. Let's check now. It is giving okay, the spelling of integer is wrong. Integer integer. Let me check if there any other error is there. So it is giving me array index of bound. So it is giving array index of bound. Let me check why it is coming. It is coming at line 63. So 63, okay. So I and j are exceeding the limit. So why they are okay. I forgot to like we will in the next row we will start from 0th column. Okay, let's run it. So it is running. So let's try to submit it. Yeah, it is accepted. So in this way we can solve this problem. So this is I think second or third. Let me check. It is third problem of the backtracking section. So I hope you have enjoyed the video. So do like, share, subscribe my channel. Thank you for watching this video. Thank you.